Moving on to example 3. In this example I'll miss out part 1, which is just expanding some brackets to establish the identity. To keep the video as short as possible, we'll just concentrate on parts 2 and 3. Use the method of differences to find an expression for sigma r plus 1. Well, we can see in the identity established in the first part, it's actually an identity for 3r plus 1. So what I'm going to do is find the sum of 3r plus 1, which will be the sum of the left hand side as well. And then we'll just have to divide by 3 when we get our final answer to get the summation for just the sums of 1r plus 1. Right, so keeping track of r, I'll go from 1 to 4 to start with. Now I'm not going to evaluate what these are, I'm just going to write 1 times 2 times 3 minus 0 times 1 times 2. And then this next one, that should be a bit further down, shouldn't it? Let's just move that down. There we go. And the next one, when r is 2, we'll have 2 times 3 times 4 minus 1 times 2 times 3. 3 times 4 times 5 minus 2 times 3 times 4. 4 times 5 times 6 minus 3 times 4 times 5. And then we'll skip all the way down to n minus 2, and we'll look at n minus 1 and n as well. So this one's going to be n minus 2 times n minus 1 times n, and this is going to be n minus 3 n minus 2 n minus 1. And when we've got n minus 1 for r, that will be n minus 1 n plus 1, n minus 2 n minus 1 n, and the last one n times n plus 1 times n plus 2 minus n minus 1 n plus 1. Right, let's see what the cancelling gives us. And you can see I didn't need to work out what these numbers were. I'm just looking at the patterns. I've got 1, 2, 3 minus 1, 2, 3. So this time the diagonals that are crossing things out are going the other way. The one on the left is the higher row and the one on the right is the lower row. So they would cancel out like that. And then you can see we've fully matched here n minus 2, n minus 1, n, and that last one. So what does that give us for our formula for this summation? Well, in this top bit here you can see 0 times 1 times 2 is just 0, so that's not going to contribute. So it's actually just going to be n plus 1, n plus 2. So therefore the sum of r equals 1 to n of r plus 1 is going to be 1/3 of n plus 1 n plus 2. And again, I'm not going to bother checking that because the next part of the question asks us to do the same thing using the standard formulae. Now that's something we did during our lower 6th AS level year, if you like, and it's often mixed together, these two things in the same question, so it's a good idea to have a look at an example and refresh it. So what I'm looking for now is the sum of r plus 1 from r equals 1 to n, and that's equal to the sum of r times r is r squared and r times 1 is r. Now if you recall what these are, it's 1/6 n plus 1 2n plus 1. That's the formula for the sum of the squares, and the formula for sum of r is a half n plus 1. Right, so it's a case of collecting these together. Never give away factors you've already got. We've got n plus 1. I would like to get the sixth at the front, so I'll just rewrite this once and say this is a sixth n plus 1, 2n plus 1, and instead of a half I'll write 3/6. So it's 3/6 n plus 1. Now let's look at the common factors. I've got 1/6 of the common factor, n is a common factor, and n plus 1. Rebuild the expression. To get the first term, the left hand side, I just need to multiply by 2n plus 1. And to get the right hand side, I've got the n, I've got the n plus 1, I've got the sixth, I just need to multiply by 3. So that will be 1/6 n plus 1, and in this bracket I've got 2n plus 1 plus 3, which is 2n plus 4. And you can see there's a common factor of 2 there. So that can be written as multiplied by 2 brackets n plus 2. And finally 2/6 is 1/3. So we get 1/3 n plus 1, n plus 2, which is the same result as we got using the method of differences. And that concludes this session, and now you can move on to work your way through the exercise on differences in the textbook.